Okay, today we're going to start talking about Chapter 9, where we're going to take moles and mesh that with balanced equations. The career specialist for this chapter is an environmental scientist, and they monitor air pollution, air quality, soil, water, radiation. They specialize often in one area, like air quality or hazardous waste. They monitor both indoor air quality and outdoor, and will assist in cleanup and remediation efforts if there's a significant problem. Section 9.1, talking about conservation of mass. And today we're going to talk about how the total mass of reactants and total mass of products must be equal. The law of conservation of mass indicates that in an ordinary chemical reaction, by the word ordinary means an everyday chemical reaction, such as the ones we would see in the lab or happens every day. The difference would be if there was by chance some sort of nuclear reaction, that the law of conservation of mass doesn't apply. But it does state that matter cannot be created or destroyed. There is no change in the total mass of a reaction, and the mass of the products must be equal to the mass of the reactants. Tarnish, silver tarnish, also known as silver sulfide, forms when silver reacts with sulfur in the air to form this silver sulfide. If I look at the law of conservation of mass and the balanced equation, I see that 2 silvers, or 2 moles of silver, and 1 sulfur, or 1 mole of sulfur, makes 1 silver sulfide, or 1 mole of silver sulfide. So that information we get from the balanced equation. Then I look here and I see this is the molar mass of silver, and there are 2 moles of silver, so I take 2 times 107.9, and it comes up to be 215.8. I see that there's 1 mole of sulfur, 32.07 grams. You can see here 32.1 grams, rounding up. And the molar mass of silver sulfide is 247.9 grams. And here the silver sulfide is 247.9 grams. So if I add up this mass and that mass, the silver and the sulfur, I get 247.9, which is the same mass as the mass of the products. So in the chemical reaction, mass of the reactants is the same as the mass of the product. So in a balanced equation, we can really get a lot of information. In addition to getting formulas of reactants and products, we get the coefficients from the balanced equation, which tell us the number of atoms on both sides, and that multiplies up. If I had 2 atoms and 1 sulfur atom, and I had 200 silver atoms, I would need 100 sulfur atoms. So that ramps up. Same thing if I have Avogadro's number, I would have 6.022 times 10 to the 23rd times 2 silver atoms, and I would just have 6.022 times 10 to the 23rd sulfur atoms, and I would have the same number of formula units of silver sulfide. But we can ramp that up because we know that the Avogadro's number is the same way of saying 1 mole. So if I had 2 times Avogadro's number of silver atoms, I would have 2 moles of silver. 1 mole of sulfur and 1 mole of silver sulfide. If I take that and multiply it by the molar mass of silver, the molar mass of sulfur, and the molar mass of silver sulfide, I see that the masses on both sides of the equation are equal. So here we have a combustion reaction where we have methane, CH4, reacting with oxygen gas to produce carbon dioxide and water. So it's just a basic combustion reaction. If we look at calculating the total mass of reactants and products, the calculations would look something like this. So the first thing we want to do is find the molar mass of all the reactants and all the products. So we have CH4, carbon, and 4 hydrogens. Molar mass of carbon being 12.01 and hydrogen being 1.01. That adds up to be 16.05 grams per mole. Then when I look at oxygen, I have 2 of those at 16, and that adds up to be 32 grams per mole. When I move over to the product side, for CO2, of carbon and oxygen, 1 carbon and 2 oxygens, carbon being 12.01, oxygen being 16. That molar mass adds up to be 44.01 grams per mole. And then for water, hydrogen, 2 of those, oxygen 1.01 for hydrogen, and 16 for oxygen, coming up to be 18.02 grams per mole. So there's all my molar masses of all of my reactants and my products. If I then come in and multiply by the number of moles or the coefficients from each of the balanced equation, so for CH4, that would be 1 mole, so it's 16.05 grams. For oxygen, because the coefficient is 2, I multiply that by 2 moles, and that is 64 grams. For carbon dioxide, that's only 1 mole of carbon dioxide because the coefficient is 1, so that's 44.01 grams. And for water, because its coefficient is 2, I got to multiply it by 2 moles, and that comes up to be 36.04 grams. So there's my total, my masses of all my reactants and all my products. If I come in and I add up my reactants and products separately, so my reactants are going to be 16.05 grams plus 64 grams, and that comes up to be 80.05 grams for reactants. And then I come over here on my products, 44.01 grams and 36.04 grams. Add those up, and I get 80.05 grams for my products. So as we can see here, the mass of the reactants, 80.05 grams, mass of the products, 80.05 grams, those are equal. So here we're just summarizing what we just talked about, that the methane and the oxygen produce carbon dioxide and water in a ratio of 1 mole of methane to 2 moles of oxygen, producing 1 mole of carbon dioxide to 2 moles of water. Adding up the masses of both reactants and products, we get to be the same mass of reactants and products.